Okay, so today's a bunch of stuff that you've probably heard before. May have been a while since you've done anything with this. But today we're going to talk about perimeter, circumference, and area. I will warn you after going through the second hour, there's a lot of information today. I don't think any of it is very hard, but it's a lot of information. So we're just going to kind of roll through it all. I've got a bunch of it typed up and kind of spells out for you, but most of it's just using and putting everything here just kind of into an example. So perimeter, circumference, and area. Okay, perimeter, hopefully a word you've heard before. Perimeter, the sum of the length of the sides of the shape. I think about it as the distance around the shape. Okay, the distance around. Since this is a distance, when we talk about perimeter, okay, the unit is just going to be feet or inches or centimeters. Okay, we're just talking about a distance. Circumference, it's kind of like the perimeter of a circle. It's the distance around the circle. But perimeter is adding all of the sides. A circle doesn't have sides, so it has a special name, circumference, but it's comparable to perimeter. Okay, area is the space inside the figure. Okay, so technically it's the number of square units that you could fit inside that shape. Okay, now depending on what kind of shape you have, how you find the area is going to be different. How you find the perimeter, you're always going to add the sides. Okay, hold on a second. There you go. You're always going to add the sides, but the area can differ from shape to shape. So first of all, if I have a square, what's so special about a square? All the sides are equal. So if I have a square that has side length S, it means all four sides measure S. So if I wanted to find the perimeter, you'd have to add all four sides, but it would be S plus S plus S plus S, which is just 4S. If you wanted to find the area, typically with area for squares, rectangles, parallelograms, you multiply the base times the height. Now with a square, the base and the height, the length and the width are the same. So you'd be taking S times S, which whatever the side length is, you're just going to square. So squares are pretty easy to deal with, okay? Let's jump down here to rectangles because rectangles are very similar to squares. So for a rectangle, the sides aren't necessarily the same. They could be, but they're not necessarily the same. But I may have, okay, this side that's H and this side that's B. So the base is B, the height is H. To find the perimeter, you would add all four sides. And I think what happens with perimeter is usually we'll only label two of them, but we know with a rectangle, if that bottom is B, the top is B. If the left side is H, the right side is H. So you have to make sure you add all four of the sides. So technically you could do H plus B plus H plus B, but kind of a condensed way of doing that, you would do B plus B, which is 2B, and H plus H, which is 2H. You could also do H plus B, B plus H, 2 times, which is where that one comes from. Now for area, you're going to multiply them together, base times height. Okay, so squares and rectangles, pretty simple. Triangles is really related to a rectangle in a way. First of all, if we wanted to find the perimeter, just going to add all the sides. So let's say for this triangle, if this side was A, the bottom was B, and then the other side is C. And then let's say this triangle has a height of H. The big thing that you have to understand with the height, although C may look like the height, it's probably close to its height. The height has to come from the top of the triangle straight down to the base. Okay, so you have to have another measurement for that. So to find the perimeter, you would just take A plus B plus C. Okay? To find the area, you kind of do what you would do with a rectangle. You're going to take base times height, but the thing with a triangle is half of a rectangle or a parallelogram. A parallelogram is going to have the same formula. So if I were to take this triangle, like double it, make an exact copy of it, and fit it together, it would create a parallelogram. And if I were to find the area of that parallelogram, I take base times height, but you only need half of it. So only one of the triangles. That's where that comes from. Okay? And then lastly is going to be the circle. Okay, now with the circle, there's two different ways that you can be given information about a circle. Okay? So we could have what's called the radius. So the radius, that's not very center, but the radius is going to start at the center point and go outward to any outside area, okay? That's the radius. It's the halfway point. It's just half of the circle, okay? Sometimes you might be given the diameter. The diameter is all the way straight across the circle through the center. So for relationship-wise, the diameter is all the way across, the radius is halfway across, so the radius is half of the diameter, okay? So to find the circumference, and remember the circumference, it's like the perimeter of the circle, okay? There's two ways you can find it depending on if you're given diameter or radius. You could take pi times diameter, or you could take 2 times pi times r. Because the radius, you would need 2 of them, right, half and half, to give you the diameter. It's the same formula, but it's saying, okay, the diameter is just the radius times 2. Okay, so 2 formulas there. For the area, you can take pi times r squared. So the area, you have to have the radius. For circumference, you can use radius or diameter, but for area, you have to have the radius. Okay? All right, and then the last thing, the postulate that you guys put into your flip book was postulate 110, which is the area addition postulate. It's kind of similar to the segment addition postulate and the angle addition postulate. Basically, part plus part equals whole. So if I wanted to find the area of an irregular shape, like this here, I couldn't just take length times width because it's not just a rectangle, it's not just a triangle, it's a couple of shapes put together. So what you can do is you can take this shape and you can do one of 2 things. You could break it into 2 separate rectangles, and you could find the area of this rectangle, and you could find the area of this rectangle, and you could add them together. Okay, so for this one, it'd be the area of the red plus the area of the blue would be the total area. So breaking apart, area addition. This area plus the other area would give you the total area. The other option, kind of in an opposite way that you could do, which we may have to do today, is kind of like almost an area subtraction postulate. So the other option here is maybe I could complete the big rectangle. So I could say, well, what if I made it a big rectangle, right? And I could find the area of the big rectangle, but then if I don't need this area, what would I do with this area? You'd subtract that area. Either way, you get the same answer. They're both kind of apply to the same postulate. Questions on any of that? All right, this is on page 15. Get that glued into your notebook. Make sure you fill out your table of contents. This is section 1.8. Perimeter, circumference, and area. When I check your notebooks tomorrow, I will be checking your table of contents as well as your chapter 1 vocabulary. The table of contents and vocabulary together are worth 5 points. So if you need to catch up on any of that, make sure you do that by tomorrow. I will check those tomorrow. All right, so we're going to do a little bit of drawing today. I mentioned I don't think what we do today is very difficult, but it is a lot. Okay, there's a lot of going on in this section here. So first thing, let's find the perimeter of the figure. So we're going to draw a rectangle. I think we can probably all handle that. So a rectangle here. Now how you are going to know for sure it's a rectangle is that the picture in the book is going to have these markings in the corners, which mean right angle, and it's going to have these markings here, which mean what? They are congruent, right? Now remember, since the 2 sides are marked with 1 hash mark and the top and bottom are marked with 2 hash marks, it does not mean that the sides and the bottom are congruent. It means the sides are congruent to each other, the top and the bottom are congruent to each other, okay? And we might also say that the side is 3 feet and the bottom is 6 feet. Okay, and we want to find the perimeter of the figure. Okay, perimeter, what do we do for perimeter? Right, 2b plus plus 2h. Okay, I have two bases, right? Although they only mark two of them, 6 and 3, I know that if the bottom is 6, the top is 6, and if that side is 3, this side is 3, right? There's 4 sides. Now, although you can probably do this in your head, great, super happy for you, you need to write down what you are doing, okay? So, to find the perimeter, okay, we would take 2 of the base, right? We have 2 sides that measure 6, and we have 2 sides that measure 3. Or if you want to write out 6 plus 6 plus 3 plus 3, that's fine too, if that's what you're going to do in your head. But whatever you're doing in your head, write it down, okay? 2 times 6 is 12, 2 times 3 is 6, so we have 18 feet. Make sure we're putting our units on our answers today. And perimeter is just a distance. Just walking around it, it's just a distance, so it's just feet. Okay, circumference. Pretty much your perimeter, but of a circle. So, number 2. Okay, so we've got this circle. And for this one, okay, they're going to tell me that all the way across the circle is 17 inches. Now, the directions, you need to pay close attention here. It says find the circumference in terms of pi. What this means is I want an exact answer. Okay, so I'll show you what your answer is going to look like. When we talk about how am I going to find this? Am I given, I guess, first of all, what information am I given? What is that 17? It's the diameter. So we have 2 formulas for circumference. We have pi times diameter or 2 pi r. In this case, all we have to do here is take pi times diameter. Now, when it says find the circumference in terms of pi, it means you want to leave the pi there. Okay, you don't want to evaluate it using 3.14, but a better answer, kind of treat pi almost like a variable, that if this was x times 17, you would probably rewrite it as 17x. So we want to throw the pi at the end, we'll call it 17 pi. It's not a variable, because I know what it is, it has a value, an exact value, but we'll throw the pi at the end. And then we'll throw our units here, it'd be 17 pi inches. Circumference is also a distance, so it's just inches, just feet, centimeters, whatever it may be. Okay. Number 3, what about for this circle? This time they give you that distance is 6.3 centimeters. What's different about this one? They gave you the radius. So this time we're going to have to say, to find the circumference, this time we're going to take 2 pi r. Okay? So 2 times pi times r, which is 6.3. Now, I don't want to take 2 times pi to estimate that, but to make this a little bit simpler, I can take 2 times 6.3, and you get 12.6. We want to write it in terms of pi, so we're going to leave the pi as it is. And once again, circumference is a distance, so it's just going to be centimeters. So it'd be 12.6 pi centimeters. Questions on circumference? Okay, this one's kind of fun. So I'm going to give you a few points. We're going to graph those points, and then we're going to find the perimeter of the figure. So let me give you these points, okay? So I'm going to give you 3 of them. So point A is going to be at 3, 6. B is going to be at 3, negative 2. And C is at negative 3, negative 2. Now, before I graph it, let's see if you guys can figure this out. I have 3 points. When I graph these 3 points, what kind of figure is it going to be? A triangle, thank you very much. Yes, a triangle. Good guess, though. Okay. Okay, so to graph this, we're going to have to, you just draw it on your paper. It doesn't have to be perfect. But whenever you're getting ready to draw your x and your y axis, you might just take a look at your x coordinates, 3, 3, and negative 3. My x-axis just has to go from 3 to negative 3. My y-axis, 6, negative 2, and negative 2 needs to go from 6 to negative 2. So what I may do is have it draw something like that. Okay, so my x-axis needs to go out to negative 3 and to positive 3. My y-axis only needs to go down to -2, but it has to go up all the way to 6. Might make your drawing a little bit easier, conserve a little bit of paper, if you kind of think ahead like that. And then I just need to take these 3 points and plot these 3 points. So first one is 3, 6. So write 3 up 6. That's point A. 3, -2. So write 3 down 2. That's point B. And then point C is -3, -2. So left 3, down 2. And then just like your little connect the dots that you used to do, connect all those together, and would you look at that? It creates a beautiful little triangle there. Now I think the ones on your homework, I think they give you 4 points, and I'm pretty sure they're all rectangles, I think. Okay, so you're not gonna have to work as hard as we are here. I know it has an extra point, but here's what we're gonna find out here. To find the perimeter, what do I need? I need the length of all these sides. So let's remind ourselves about our notation here. The length between points A and B, remember we just write it as AB equals. Okay, no line over it because we're just talking, if you're just talking about the length, you just say AB equals. Now, since I drew the picture, I mean, I could kind of just look at it, right? AB, okay, -2 to 6, right? -2 to 6, what's that like? 8. Okay, well, that was easy, right? What other side would be pretty easy to find? Yeah, CB, because it's straight across, right? So CB goes from -3 all the way to a +3. What is the length of CB? 6. Okay, so 2 of the sides are pretty easy to find. Now, on your homework, like I said, I think they're all rectangles, so I think you can do that for all of the sides. I don't think this happens on your homework. It might. How am I going to find the length of AC? Can't just count. The Pythagorean theorem. In a way, yeah. This actually works really well for the Pythagorean theorem, doesn't it? Because I know that that's 8 and that's 6. It's the distance formula, isn't it? Your change in x is 6 because look, from A to C, your change in x from 3 to -3, isn't it 6? And your change in y, although yes, I already found it, okay, should be 8, but look, from 6 to -2 is 8, okay? So to find AC, okay, we're going to take 6 squared plus 8 squared. And remember, that'll give you c squared. You don't want c squared, so that's why we take the square root. So we take 36 plus 64. Still need to take the square root of that, which would be the square root of 100, which would be 10. So AC equals 10. Okay, so I have my 3 side lengths. What do I do with these? Add them together. 8 plus 6 plus 10 should give me 14 units. 14 units. 24 units. 24 units. There we go. Okay. Yeah? Is that right now? Okay. All right. Okay, so next let's talk about area. So if I want to find the area of a rectangle, let's say I want to find the area of a rectangle that has dimensions 5 feet 2 inches by 3 inches. I want to find the area of that rectangle. First of all, how do you find the area of a rectangle? Yeah, multiply these sides. So I need to take 5 feet 2 inches by 3 inches. What's the problem with taking 5 feet 2 inches and multiplying by 3 inches? I've got different lengths, right? I can't mix the feet and the inches. Anybody have a solution? Yeah. Let's change it all into inches. How do you change 5 feet into inches? There's 12 inches in a foot, so I take 5 times 12. That gives me 60 inches. Is that side 60 inches? It's 62 because it's 5 feet 2 inches. So my rectangle is 62 inches by 3 inches. So if I were to multiply these together, I should have 186 inches. Now, if I were to tell you, oh, that rectangle is actually, 186 inches squared, that's a lot of inches, and it's kind of hard to think about, okay? So what would be maybe a little bit better answer is turn it back into probably a mixture of feet and inches. So how would I go from 186 square inches into feet and inches? Divide by 12. Now, when you take 186 divided by 12, you get 15 and 1/2 feet squared. I don't really want the half of a feet squared. What would that be? Yeah. So it'd be 15 square feet and 6 inches squared. That's kind of, maybe I should leave it like that. I'll need to look up and see what it is. Maybe include both answers for your homework. Either one would probably be fine. Now we're almost done. Like I said, none of it's, I don't think, super difficult, but it is kind of a lot. You guys have questions so far? Okay. Now for these ones, we want to find the area of the circle. Area of the circle, okay? It says we first want to find it in terms of pi, and then approximate by using 3.14. When you get to your homework, this is actually going to be in 2 sections. Some of the problems are going to say, find the area in terms of pi. And then the next set of problems is going to say, find the area, approximate the area using 3.14, but I'm going to combine them all in one, okay? So let's say we've got this circle. Okay, and I'm going to give us a kind of a tricky one because you're going to have one of these in your homework. Let's say the distance all the way across is 7/8 inches. Now, if I want to find area, what measurement do I need? I need the radius. Okay, remember, because area is pi r squared. Well, if I'm given the diameter, how do you get from the diameter to the radius? Divide by 2. Now here's the thing, it's a fraction, which is not a huge deal. You could take 7/8 divided by 2. But another way to divide by 2 would be to multiply by 1/2. Same thing, right? Okay, I think that's probably easier when it comes to a fraction. So the radius is going to be 7/16. 7/16 inches. Okay, so to find the area, we're going to take pi r 7/16 squared. Now, to write this in terms of pi, we're going to need to square the 7/16, and then to leave it in terms of pi, we'll just put the pi at the end. So 7/16 squared is just 7 squared over 16 squared, which would be 49 over 256 pi, and then area is always going to be a units squared. So in this case, it's going to be inches squared. So that would be your answer in terms of pi. And then to turn this into an approximation, it says use 3.14 for pi. So in your calculator, you would just take 49 over 256 times 3.14. If you want to practice that, you can. And I believe it gives you about 0.16. I think at home I asked Alexa to do that, and sometimes she's not super good at math, so that could be wrong. But I think it's right. Perfect. Alexa was right. Okay. Questions on that one? Okay, last thing. Talking about that area addition postulate. Okay, we want to find the area of this shaded region. So I want you to draw a big rectangle. Okay. And then I want you to draw a smaller rectangle on the inside. And then my shaded area is going to be kind of like the frame almost. So we want to find the area of kind of the rectangle just without that middle inside. And here's the measurements they're going to give you. Let's say that whole side is 10 feet. This whole side is 15 feet. And then what it's going to look like in your book to show you this, what that measurement is right there is 4 feet, and then this measurement here is going to be 5 feet. You know, what I like to do is I kind of like to come up with a plan. Don't think about the numbers, okay? Just think about a plan. If I didn't give you any measurements and I said, how would you find the area of the shaded region? Sometimes I think that's easier than whenever they slap numbers up there. Well, how would you find the area of the shaded region? So we find the area of the whole thing. I'm going to kind of go backwards what you said. But the thing is, I don't need the whole thing. I don't need that middle part. So if I can find the area of the center, I take the area of the whole thing, take away the area of that center. Well, area, we're going to take length times width. So to find the area of the whole thing, what would you multiply? 10 times 15. So the whole thing is 150. Okay, the center, that's a rectangle as well. How would you find the area of the center? 5 times 4, so 150 minus 20 would be 130 feet squared. Area is always a square unit. Okay, questions?